So a lot of cars in this class run with a standard and classic McPherson strut front suspension, and there's not a lot wrong with the McPherson strut front suspension. It's light, it's durable, and it's very, very tough. But when you use it in conjunction with some of the higher powered engines, some of the compromises inherent in the design become a problem. It's very difficult to eliminate torque steer from a classic McPherson strut, for example, and because the whole of the strut is twisting during the steering action and you have varying friction within the strut, the ability to fine-tune steering feedback becomes very difficult. So for Astra GTC we've adopted the Hyperstrut front suspension, which is adapted from the Insignia VXR vehicle. Same concept, but specifically tuned and designed for Astra GTC. So in the Hyperstrut front suspension, instead of the whole strut steering, the strut is held static and the steering action is contained between an upper and a lower ball joint. We can see the graphic here. The Hyperstrut front suspension, the yoke which is held static, the upper ball joint and the lower ball joint around which the steering is accommodated. Again, in this model we can see that the steer happens just between the ball joint. The net result of that is that we've been able to dramatically reduce the kingpin inclination, about a 41% reduction in what you can typically achieve with a McPherson strut, and also reduce the kingpin offset by a similar percentage. Now the reduced KPI, a kingpin inclination, means that on the front steering wheel the positive camber is very much reduced. In fact, we can maintain a neutral camber on the front steering wheel, which means the tyre stays in much better contact with the ground and you get a much better steering feel precision and feedback. The reduced kingpin offset means that all of the out of balance forces that are generated in the wheel, all of the torque steer forces generated through the CV joint, have a much lower moment to work on, which means much less interference with the steering action and a much crisper, smoother, purer steering experience. Again, we can see here in the graphic a comparison between the classic McPherson strut with the strut bolted directly to the upright, and in Hyperstrut the strut is bolted to the yoke, which again is located to this lower suspension arm, and the steering knuckle located between an upper and a lower ball joint. Here we can see in the graphic that the wheel and upright are turning. The strut, although we can see some reflected light in the strut is actually static. Now the rear suspension is the compound crank axle with the additional location from a Watts link. So here's the compound crank axle, the Watts link in blue mounted to a separate cross member, again mounted to the body. The advantage here is that the Watts link can take out all of the side forces encountered in cornering, meaning that the twist beam can be specifically designed for roll stiffness, wheel location and comfort. In fact, we've been able to go back to orthogonally mounted location bushes. These bushes no longer have to compensate for toe aberrations in cornering. They can just get on with the job of providing compliance and articulation. Compared to the Astra hatch, the GTC twist beam is a much stiffer item, but also by being able to rotate the section, we've been able to relocate the roll centre of the rear suspension to get a much more involving handling balance for the car, much more driver focused, handling focused balance. The steering for Astra GTC is electronic power steering, with the steering mounted directly to the rack. The motor here, as you can see, is mounted directly to the steering gear, the control unit directly to the motor, and the sensor unit on the steering gear input side, which means we've got the whole unit mounted very rigidly in an integral unit, which again helps us get great feedback into the steering system.